Okay, for section 12.6, we're going to look at scatter plots, correlation, and regression lines. And before we dive into the scatter plots and the correlation, I do want to let you all know that this is all just kind of going to lead into the idea of linear regression. Okay. And so we're going to kind of talk very briefly about the idea of linear regression, then we'll look very specifically at scatter plots, correlation, and then we'll practice the linear regression part. So as a definition, whoops, that'll work. So we have that linear regression is a method used to describe the relationship between two numerical variables. Okay, so we're going to have variables that have some kind of like numerical value associated with those. This process finds the equation of the line that best represents the data points. This line is called the line of best fit or the regression line. Okay, and the whole point behind linear regression is when you're looking at real world data, it's rarely going to fall like exactly on a line. You're going to have data points that kind of hover around a line. Okay, and so we can't say that for sure that if X is this, then Y has to be this, but we can say, hey, based on this data set, with this equation that best represents this data set, we can say that if X, then Y should be approximately this thing. Okay? So linear regression can be used to make predictions about the data set, and it can be, you can see with linear regression if there is a positive or negative trend to that data set. Okay? So just as a quick, for instance, let's say we had a data set that when we graphed it, it looked like this. Okay, so you can see that while these data points are not exactly on a line, they're definitely hovering around a line. So while there's not a single line that's going to catch every single data point, there is a line that is going to best represent this data set. Okay, and that would be a line kind of like that. Okay, that is our goal. We want to find the equation of the line that best represents this data set. Okay, so let's say, for instance, we let X equal hours spent studying, and Y was some final exam score. So let's say you're getting ready to study for your Math 143 final exam. We record every single Math 143 student on campus, and we ask them to tell us how many hours they spent studying, and then we look to see what their final exam score is. We want to know, is there a trend? For example, if we increase the hours spent studying, do we see an increase in corresponding final exam grade? Okay, so Y could be final exam grade. So our goal would be to see, is there some trend? Is there a relationship between time spent studying and final exam score? And you would assume that there probably would be. We can imagine if you don't study at all, you might have a lower exam score versus somebody who studies a bunch. They would ideally have a higher exam score. So that's kind of what we're looking at. We're looking at real world data. So each student that we look at would have a single point, some XY combo. So we could say student A has some X1, Y1 data point. Student B would have some X2, Y2 data points. So each student that we look at would have their own data point, and each data point would represent one of these dots. We then use this process to find the equation that best represents that data set. That's the idea behind linear regression, okay? Now, topic one is just going to look at scatter plots, okay? So I've kind of explained scatter plots to you a little bit because this right here is a scatter plot, okay? So a scatter plot is just a collection of data points that we would plot on the Cartesian plane, okay? So we would have some kind of XY axis situation and we would plot some data points, okay? Now each point represents paired data, that's a typo, paired data values, okay? And those paired data values would come in the form of an ordered pair XY, and there's going to be one data point per person or object. So kind of like that hours spent studying and final exam score. Every single student would have an individual ordered pair that represent their particular situation, their hours spent studying and their corresponding exam score. Okay. And by looking at scatter plots, we can see visually, are there trends or relationships or correlations between the two variables that we're looking at? Okay. So I have four pictures here. I do want to caution you, if you have the printed notes, you might have printed notes with a typo. I copied the wrong graph in, so I'll point that out when we get to the specific one. But here we have four scatter plots. You can see none of these points are exactly going to be a line or a parabola or so forth, okay? But they're close, all right? So we can see for this first graph, we do have a linear relationship between these data points. You can see that there would be some line, ideally, that would do something like this, okay? For the second data set, it very much appears to be quadratic. The points increase, they go to this maximum point, and then they decrease. So while they're not exactly a parabola, they're close. Okay. For the third graph, this is where you may have the wrong graph in there. You may have like a little, I don't want to call it a typo, a copy and paste goof. But if you have the same graph that we have right here, just exit out and draw kind of this graph. So what I have on my screen is correct. This data very much looks logarithmic. It shoots up, it has this rapid start, and then it kind of levels off, okay? So we can see that while these points are not exactly on a graph, they're really close, okay? And then finally, the last graph should represent something that's exponential. The growth starts off really slow, and then it has this explosive growth. Okay, so again, for all four of these, we have points that are not exactly on a graph. Okay, they're not exactly on a parabola, they're not exactly on a line, they're not exactly on something logarithmic or exponential, but they're really close. Okay, so scatter plots can be used to see if there is some kind of trend in your data set. All right, so what I want to do for example one is you've got two data sets here. They're just very generic. They don't mean anything. They're just numbers. Okay. But what we're going to do is we're going to create a scatter plot. So we'll first do them just by hand, and then I want to show you how you can get a calculator, so like a TI-84, to do a scatter plot, and then how you can get Desmos to do a scatter plot. Okay, so we're going to do them by hand, Desmos, and calculator. All right, so it says, for example, one, create a scatter plot for each data set and determine what, God bless, I have so many typos here, what type of relationship exists, okay? So for the first example here, part A, we have X values of 1, 6, 4, 3, 7, and 2, and then corresponding to each of those X values is a very particular Y value. The Ys are 2, 5, 3, 3, and 4. So you need to read these as if they were ordered pairs. The first ordered pair, we have X is 1, and for that X, we have to have Y is 2. For the second ordered pair, we have 6, 5, then we have 4, 3, 3, 3, 7, 4, and 2, 1. Okay, so just make sure you understand how to read the table. For each X, there is a corresponding Y. You can't just mix them up any old way you want. For each X, there's a specific Y. Okay, so let's see. From our table, we have the ordered pair 1, 2. So I would plot that. That'd be right about there. Then we have 6, 5. So let's see, 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. Next we have 4, 3. So 1, 2, 3, 4, up 1, 2, 3. We have 3, 3. So from the origin, 1, 2, 3, up 1, 2, 3. And then we have 7, 4. So from the origin, we go to the right 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3, 4. And then finally, we have 2, 1. So from the origin, we go to the right 2, up 1. So you can see these data points are not on a line, but you could envision a line kind of going through these data points. So there very much appears to be a strong, I would say there's a pretty strong relationship here. Positive, because the line is going uphill, so think like the slope is positive. So there is a strong positive linear trend here. Okay? So that's how we would do this just by hand. You would plot the points. Okay, now I will show you in just a moment how to do these on the calculator and then how to do them on Desmos. So for part B, we have x's of -2, -1, 0, 1, and 2. And then f of x, which remember, if you go back a ways back, like back to chapter 7, we know that y equals f of x is just function notation. Okay, so in this case, we have f of x, which is the same thing as a y. We have 8, 6, 5, 6, and 10. So the ordered pairs that we're really looking at would be -2, 8, -1, 6, 0, 5, 1, 6, and 2, 10. So let's plot those. So we get negative 2, 8. So to the left 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. And then we have negative 1, 6. So to the left 1, and then up 1, 2, 3, 4, 5, 6. 0, 5. So I stay at the origin, and then I just go up 5. 1, 6. So I go to the right 1, and then up 1, 2, 3, 4, 5, 6. And then finally 2, 10. So at the origin, I go to the right 2, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're not exactly on a parabola, but you can see they're pretty close. All right. So I would say there is a strong quadratic, because remember, quadratic is a parabola, strong quadratic relationship. Now, after this example right here, we're really just going to focus on linear relationships, okay? So let's go ahead and go, let me make sure I've got these typed out in front of me. Let's go to the calculator first, okay? So we're going to switch to the graphing calculator. Is that the screen? Yes. Okay, so we've got our graphing calculator here. We have to set the stage so that the calculator knows to plot individual data points, okay? So I want to show you how to turn this on and turn this off, okay? So if you want to turn the like plot of points on, all you have to do is go to the, well, there's two ways to do this. We're going to do it just one way, and I'm going to kind of stick to that. You can just go to y equals, okay? I'm going to clear out the stuff that's already there. We don't need that. But what I want to point out to you is above y1, y2, y3, y4, we have plot 1, plot 2, plot 3. So if I hit the up arrow, it'll highlight on plot 1. If I hit enter and then go down, that plot is on, okay? If I go back up and hit enter and then go back down, I've turned it off. So if we go up, hit enter, it's on, up, hit enter, it's off. That is the quickest way to turn the plot on and off, and that's how I'll typically do it. Now, there is another way. So from the home screen, if you look at that y equals button, notice in blue it says stat plot. So if I go second y equals, it's going to take me to this other screen that has a bit more information about the plot feature. So notice plot 1 is off. So if I go over or just click on it, this one's a little different. So we're going to click on it. I can see here that I have on and off. I want to turn it on. And then you can choose the type of graph you're going to get. We want this first one where it just plots points, okay? And then notice your X and Y list. Your X and Y list are L1 and L2. What that's going to do is it's going to take the X values into L1 and the Y values into L2. So for us, we need to make sure that when we type in our data points, we use L1 for X's, L2 for Y's, okay? And then the mark, it's going to just be this little box. And then depending on the type of calculator you have, if you have the newer, fancier calculators, I think they do color. Most of them won't do color, though. They'll just do black, okay? So if we go just to that Y equals button, you can see it turned on plot 1. So again, I can go up, hit enter, it turns it right back off. I can go up, hit enter, turns it back on. Again, if you want the details, you would go second Y equals, and you can see here it says plot 1 is on. If you hit enter, it'll take you where you can change the details. You can turn plot 1 on or off. You can change the type of graph. For us to do a scatter plot, we're going to leave it just like this. And then we want L1 and L2 for the X and Y list. You could certainly change this. You could change this to L3 and L4. You just need to make sure you type your X's and your Y's in L3 and L4. And then I'm going to leave the mark as is. Okay? So it's important that you know how to turn the plot on and how to turn the plot off. Again, just go to Y equals, hit the up arrow, and then hit enter to turn it on or off. Okay? Now, to input a data set, you want to go to stat. Okay? Just like we did to find the mean, the median, the mode, all of that, same exact thing. We're going to go to stat, and the very first menu is edit, and we want to choose the first option in the first menu. We want to edit a list. Okay, now I have some junk in there already, so I want to clear out the old stuff. So remember, to clear out a list, you just hit the up arrow, hit clear. It doesn't look like anything happens until you hit the down arrow, then the data is gone. Okay, so for example 1, part A, we had X values of 1, 6, 4, 3, 7, and 2. It is really important that you type the X and Y list in the order they are given to you. Because remember, for this X, it corresponds to this Y. So you have to make sure your order pairs match up correctly. So don't try to do anything weird. Type them in exactly the order in the table. All right, for the Ys, we had 2, 5, 3, 3, 4, and 1. Okay. So at this point, if you were to go ahead and hit the graph button, you should potentially see these points depending on what your window is on. So I can see my data points right here, but they're kind of scrunched. And the reason for that is the window settings. So another thing that you can do is when you have your graph screen up or just even the home screen, it doesn't really matter. The top row of buttons, go to the second one that says window. This allows you to change the width and like height of your window. Okay. So right here, I have my X min set at -10, but my X max set at 60. I don't need any of that because from the table, you can see our smallest X value is 1. Our largest X value is 7. So as long as 1 and 7 are included, we're good. So let's say the X min is actually 0 and the X max is 10. So that's going to set my X axis from 0 to 10. And then for X scale, that's going to be how we increment. So let's just set that at 1. So we'll increment by 1s. Now, if we look at our list of Ys, our smallest Y is 1, our largest Y is 5, so we could go 0 to 10 again. So 0 for the Y min, 10 for the Y max, and again, let's just set the Y scale at 1. And then if we hit graph now, you can see the data points a little better, and this matches what we did by hand, okay? So that was the first graph, all right? Now for the second graph, I'm going to go back to stat. I'm going to go to the edit, and I'm going to clear out the old stuff, okay? I don't like to type over it. I like to just clear it out for me. So up, and then hit clear, and then up, hit clear. All right, now remember, you have to type the data sets in the order that they are in the table. So we have -2, -1, 0, 1, and 2 for your X's. And then our Y's, we had 8, 6, 5, 6, and 10. Okay? And just double check, make sure your ordered pairs line up the way they should. And then we can go ahead and go to graph if you want. And notice here we don't see the whole picture, and that's because our X's and our Y's are a little different for this graph than for the last graph. So let's go to window again. Now, looking at my X values, they go from -2 to +2. So let's say we went -5 to +5 for our X's, incrementing by 1 again. And then for the Y values, my lowest Y value was 5, my highest Y value is 10. So let's say we do like 0 to 15 maybe for the Ys. And again, we'll just increment by 1, okay? Now when we hit graph, you can see those points, and you can see they're pretty close to a parabola. They're not exactly a parabola, but they're pretty close, okay? So that is how you can use a calculator to create a scatter plot, okay? Now next we're going to look at Desmos, okay? So in Desmos, you want to just go to desmos.com and then open Graphing Calculator, okay? And when you're on this screen right here, the first thing you want to do is over on the far left, there's this plus sign. You want to click the plus sign and then go to table. This allows you to type in X's and Y's, okay? So you can type in X, then Y, or you can just type in all your X's, all your Y's, does not matter, okay? So let's do part A again. So for part A, we have 1, 6, 4, 3, 7, and 2. And then I'm going to use my mouse to go back up to Y1. And here we have 2, 5, 3, 3, 4, 1. And hopefully you noticed that as we typed those in, let me scroll in a little bit. It was plotting little tiny points right here. Okay, so it's really, really easy to do a table like a scatter plot in Desmos. You don't really have to do a whole lot. There's no like prep work. You just type in your table. Okay, so that is for the linear graph part A. Let's go ahead and look and see what part B would look like. So again, I'm going to hit the plus sign. I'm going to add a table. And then my X's were -2, -1, 0, 1, and 2. Whoops, I don't need the 3. And then my Y values in the same order were 8, 6, 5, 6, and 10. All right. And with the way I have my screen zoomed in, you can't see them. All I have to do is click and kind of grab, and it'll pull the screen, and you can see really clearly those blue points right there. So that's how you do a scatter plot on Desmos. Okay. So either way, make sure that you can do a scatter plot by hand by just plotting the ordered pairs like we did here. Make sure you can verify with Desmos or the calculator, either one. Okay. And on your final exam, you can either use a TI 8384 calculator, or you can download the Desmos test app and you can use that for your final exam. Okay.